The next topic is binary arithmetic. So in this, under the heading binary arithmetic, we will try to understand binary addition and binary subtraction, and there is one more method called as complement method of subtraction, which will be specifically used for binary numbers. So first one, in binary arithmetics we will go for binary addition. Of course you have to follow certain rules for performing binary additions, and that rules can be understood by using binary numbers. Of course I have written binary numbers, you know already, we are well versed with binary number system. It has only two symbols, 0 and 1, and then the next higher number will be second number followed by first, then second number followed by second, and this is the highest two-digit number, and then shift one digit towards left, write the second number in the first column, first number in the next columns, and that is how you get this entire number system. So it will be 0, 1, 10, 11, 100, 101, 110, 111, and again you apply the rule, you get 8, 9, 10, 11, 12, 13, 14, 15. So these are the first 15 numbers in the binary number system. Now we have to apply the rules. So 0 plus 0, as I said, 0 and 1 in binary, it has the same meaning which it has in decimal number system. Therefore 0 plus 0, 0 added to nothing will be of course 0. 0 plus 1, that means it will be the next higher number. 0 plus 1 will be the next higher number, that will be 1. Then 1 plus 0, of course 1 plus 1 added to nothing will be 1. Then 1 plus 1, see this is very important. 1 plus 1, of course it is not decimal, it will not be 2. In binary it will be the next higher number. So 1 plus 1 will be the next higher number, that is 1, 0. So in binary 1 plus 1 will be 1, 0. Similarly 1, 0 plus 1, that means 10 plus 1. So 10 plus 1 means the next higher number, that will be 11. 11 plus 1 will be 100. 100 plus 1 will be 101. 101 plus 1, the next higher number will be 110, and 110 plus 1 will be 111. So this set of rules we have formed by using nothing but the binary number system. Now you have to apply this rule to perform binary addition. Let's take a simple example. 1011 plus 1101 plus 1011. Let's say we perform the addition. Of course, whenever we perform the binary addition, we always start with the least significant bit, the LSB. The numbers are 1, 1, 1. So it will be 1 plus 1 plus 1. So you add 1 plus 1, 1 plus 1 is 10, and 10 plus 1 is 11. So 1 plus 1 plus 1 will be 11, 1, 1 carry forward. In the next column now again you have 1 plus 1 plus 1. That means 1 plus 1, 10, 10 plus 1, 10 plus 1, 11. So it will be 1, 1 carry forward. 1 plus 1, 1 plus 1, 10, 0, 1 carry forward. And then 1 plus 1, that is 10, 10 plus 1, that is 11, 11 plus 1, that is 100. So 100. So this is the answer for binary addition of 1011 plus 1101 plus 1011. I'll take one more example so that you can understand properly. This is the first, second, say 111 plus 110 plus 101 plus 011 plus 100. Let's say add this, we add these numbers. So now again we'll start with LSB. 1 plus 1, 10, 10 plus 1, 11. So it will be 1, 1 carry forward. In the second column it will be 1 plus 1, 10, 1 plus 1, 10, 10 plus 1, 11, 11 plus 1, 100. So when you get 100 in this column, addition of these, all these numbers gets 100. So it will be 0 and 10 carry forward. So next number will be 10 plus 1. Next addition will be 10 plus 1, 11. 11 plus 1, 100. 100 plus 1, 101. And 101 plus 1, 101 plus 1 will be 110. So this is how you will perform binary addition. You can check by using 8421 code, which we have used for binary number system. So according to 8421 code, this number will be 1011 will be 8 plus 2 plus 1. 8 plus 2 10 plus 1, this is 11. Similarly 8421, 8 plus 4 12 plus 1 13, and this will be 8 plus 2 10 plus 1 again 11. So when you add this all these numbers, so this value will be 35, and check this number 100011. Now the code which we have is a 4-bit code, and the binary bit which we have is a 6-bit code. So the code becomes 1632. What you can see is it is increasing in the order of 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. So now what the number we have? 10011. Sorry, 00011. So those number which has 1 beneath that will be added, all the other numbers will be left. So it will be 32 to 1. 32 plus 2, 34 plus 1, 35. So you can verify your answer like this. The next topic under binary arithmetic is binary subtraction. It is very, very important, and please try to understand it properly. Again, we will use binary number system to get the rules. There are 5 rules which has to be followed. Of course, as I said, 0 and 1 in binary, it has the same meaning which it has in decimal number system. Therefore 0 minus 0 of course will be 0. This one is the most important. 0 minus 1. Of course 0 minus 1. If you can write, of course it will be minus 1. I'll take an example so that you can understand. I'll take an example of a decimal number system so that you can understand it properly. Suppose if it is 2 minus 5, of course you can write minus 3. But if you can generate a borrow, what happens? This value becomes 12. So now 12 minus 5, the answer will be 7. Am I right? If a borrow is available, only then you can generate a borrow, and then the value becomes 12, and 12 minus 5, the answer will be 7. So if I do the same thing here in case of binary number system, 0 minus 1. So 0 minus 1, of course the answer will be minus 1. But if I can generate a borrow, what happens? This value becomes 1. So now what is 10 minus 1? No, it's not 9. It's not a decimal number system, it's a binary number system. So you have to check the binary number system. 10 minus 1 will be the next lower number. 10 minus 1 will be the next lower number. So 10 minus 1 in case of binary number system will be 1. So we will write 0 minus 1 as 1. When it will be 1? When a borrow is generated. So with a borrow. So if you generate a borrow, this value becomes 10, and 10 minus 1, the value will be the next lower number, that is 1. Rest of the rules are very easy. 1 minus 0, of course 1 minus 0 will be 1. 1 minus 1, there will be 1 minus 1 will be 0 of course. And 10 minus 1, again 10 minus 1 will be the next lower number, will be 1. So this is the rules which we have obtained from binary number system. And then now we're applying this rule for binary number system. So applying the rule, I'll take the first example as 1000 minus 0111, or I'll say 101. I'll subtract these two numbers. Okay. So in case, again we will start with the least significant bit on the rightmost corner. So 0 minus 1. 0 minus 1. What is 0 minus 1? It will be 1 with a borrow generator. So do we have a borrow? The next lower place is also having 0. The next lower place is also having 0. So you have to generate a borrow from the MSB for the LSB to make it 10, so that we can perform the subtraction. So now what happens is, this 1 we have to take it as a borrow to the next lower place. So this 1 will be subtracted by 1. So this becomes 0, this becomes 10. So borrow has been transferred to the next lower place. From this 10, we have to transfer 1 to the next lower place. That is how we have to go up to the LSB. So 10 minus 1, 1, and this becomes 10. Similarly again, 10 minus 1, this becomes 10. And now you have to perform the subtraction. So the subtraction will be 10 minus 1. 10 minus 1 will be 1. 1 minus 0, 1. 1 minus 1, 0, 0. And again you can easily verify by using 8421 code. So according to 8421 code, 1000 means that the value will be 8, and 10101 is 4 plus 1, that is 5. So 8 minus 5, the answer is 3, and you can see the answer is 0011. 2 plus 1, 0011. 2 plus 1, the value is 3. So this is how you have to perform binary subtraction. I will take one more example so that you can understand it properly. Let the second example be, say, 11010 minus 110110. So this is the subtraction. Again we will start with the LSB, and in LSB you have 0. So 0 minus 1, what we will do is we will generate a borrow, and now a borrow is directly available in the next higher place. So from this 1 we will subtract 1, so this value becomes 0 and this becomes 10. So 10 minus 1 will be 1. In the next column again you have 0 minus 1. So subtraction is not possible. You have to generate a borrow, and the borrow is available at this place. So the borrow has to be generated from this place to that particular bit. So 1 minus 1, this value becomes 0, this becomes 10. So borrow has been transferred to the next lower place, and from there it will go to the next lower place. So 10 minus 1, 1, this becomes 10. 10 minus 1, 1, this becomes 10. So now subtraction is possible. 10 minus 1, 1, 1 minus 0, 1, 1 minus 1, 0, and here again 0 minus 1, we have to borrow generate. You have to generate a borrow, so this becomes 0, this becomes 10. 10 minus 1, 1. So this is the answer for your binary subtraction. I hope you have understood. Hello students. In the last video we did binary arithmetics, and under the binary arithmetics we did binary addition and binary subtraction. I hope you have understood that, and you have solved the examples which I gave you as quiz. Now what you can see is, in case of binary addition and binary subtraction, of course the process is very different. The rules are different, the process is different. So in case if you want to design a logic circuit which performs as adder or subtractor, then because the process of addition and subtraction is different, you have to design two circuits, one for addition and one for subtraction. So what happens is, it takes more number of space. When you design a logic circuit, it requires more number of space, it requires more number of component, and the cost of the circuit also increases as you are designing two separate circuits, one for adder, one for addition and one for subtraction. To overcome the difficulty, we now will try to understand complement method of subtraction, which is again in the under the heading of binary arithmetic. Complement method. In complement method of subtraction, we perform only addition, but the answer is for subtraction. So that is the advantage. So when you design a circuit, you have to design only one circuit which performs only addition. So if you would go by this method, complement method of subtraction, you will be performing only addition, but the answer will be for subtraction. So there are set of rules which has to be followed. I have written, we will follow these rules and we will try to set an example. The first and the most important thing is the types of complement method of subtraction. The first one which we are going to study is called as 1s complement method. 1s complement method. There are two methods, 1s complement and 2s complement method, and these two are only for binary subtraction, only for binary numbers. We will try to understand what exactly we mean by 1s complement method. Now 1s complement number is obtained by converting all ones into zeros and all zeros into ones. So whatever be the binary number which is given to you, if you want to find out 1s complement of that number, what you have to do is you have to convert all ones into zeros and all zeros into ones. That means if you take an example, say example is 1010, and you want to find out 1s complement of that number. So what will be 1s complement of that number? What it says, to obtain 1s complement of number, we have to convert, to obtain 1s complement of the number, we have to convert all ones into zeros and all zeros into 1. So for this, the 1s complement will be ones will be converted into 0 and zeros will be converted into 1. So it will be 0 1 0 1. So this is the 1s complement of the number to be subtracted. Okay, so when you're going to subtract a number, if you want to find out as per the rule, you have to find out 1s complement of the number to be subtracted, and this is how you are going to find out. I will take two examples, one for positive number and one for negative number, because if you can see the fourth and the fifth rule, it is different for positive and negative number. We will take both the examples and we'll try to understand how to perform subtraction using complement method, and that too 1s complement method. I'll take the first example, example 1, 1 0 0 0 minus 0 1 0 1. What you can see is, according to 8421 code, 1 0 0 0, it means this is 8. 0 1 0 1, that means 5. 4 plus 1, 5. So 8 minus 5, the answer, expected answer is 3, right? So we will not perform direct subtraction, we will perform only addition, but the answer will be for subtraction. That is what we have to understand, and for that we have to follow this set of rules. Now according to our rule, what the first rule says, keep the first number as it is. So keep the first number as it is, 1 0 0 0. Okay. Second rule, find 1s complement of the number to be subtracted. Now you know how to find out 1s complement. What is 1s complement? All ones converted into zeros, all zeros converted into 1. So if you find out 1s complement of this number, this will be 1 0 1 0. So these are the first two steps. Third, add the two numbers. You have to perform addition. In binary arithmetic, we have already studied the rules for binary addition. The same rules we have to apply over here. Starting from LSB, we have to keep on adding. What is 0 plus 0? 0. 0 plus 1? 1. 0 plus 0? 0. And 1 plus 1 is 10. 0 1. Right? So the third rule has been done, add the two numbers, and then we have to check either for fourth or fifth, whichever it is true. Now in this case, where we did the MSB addition, see, this is the LSB, this is the next higher bit, the next higher bit, and this is the MSB. So we have to check if MSB produces a carry or if MSB does not produces a carry. In this example, the addition of MSB produces a carry, and this carry is called as EAC, that is end around carry. This carry is called as and around carry. So which of the two conditions is satisfied? The first one, because in this case, in this example, addition of MSB produces a carry. So if MSB produces a carry, the answer is positive. That means the result, whatever we will get, the final answer will be positive. What it says next, bring down and around carry and add to the LSB of the result. You have to bring down this one and add to the LSB of the result. If bring down EAC, that is an end around carry, and add to the LSB of the result to get final answer. So if you add these two numbers, 1 1 0 0, so this is your final answer. What was the expected value? The first number was 8, the second number was 5, and the subtraction of 8 minus 5, the expected answer is 3 0 0 1 1. If you compare with 8 4 2 1, that it will be 2 plus 1, that is 3. So this is an example of a positive number. On the same lines, we can perform and we can take an example of where the answer will come negative. That means out of these two, the last condition will satisfy after the first 3 steps. So let us take an example and solve and try to understand. Let us say in this example we will take 0 1 0 1 minus 1 0 0 0. So what you can see is this is 0 1 0 1. According to 8 4 2 1, it is 0 1 4 plus 1, that is 5, and this one is 8. So 5 minus 8, of course the expected answer is minus 3. So answer will be negative. Let us try to understand how a negative number problem will be solved using 1s complement method. Again, you have to follow the same rule. What it says, keep the first number as it is. So it will be 0 1 0 1. Second, find 1s complement of the number to be subtracted. So what will be 1s complement of 1 0 0 0? All ones converted into zeros, all zeros converted into 1. So 1s complement of this number will be 0 1 1 1. Is that correct? Okay. Next, you have to add the two numbers. The two numbers has to be added. So we will start with LSB and we'll go up to MSB. So 1 plus 1, 10, 0, 1 carry forward, 1 plus 0 plus 1, that is 1 plus 1, 10 again, 0, 1 carry forward. I hope you remember the rules of binary addition. You have to follow that rules to get this addition correctly. Next is 1 plus 1 plus 1, that is 1 plus 1, 10, 10 plus 1, 11. So 1 1 carry forward, and at MSB 1 plus 0 plus 0, 1. Now after addition, what you can see is the addition of MSB does not produces a carry. In that case, we can say the fourth condition remains unsatisfied, but the fifth condition is satisfied. What is the fifth condition? If MSB does not produces a carry, the answer is negative. Of course, we already know that the answer is negative. So the answer is negative, and what we have to do is find 1s complement of the result. We have to find 1s complement of the result to get final answer. So 1s complement of this number will be 0 0 1 1, correct? And find 1s complement of the result to get final answer. Add negative sign to it. So take it in a bracket and add negative sign to it. So 5 minus 8, the answer is minus 3. I hope the picture is clear now. Let us take two more examples where you have both integer as well as fraction part. In the previous two examples, I took only the integer part as the numbers. Now we will have both integer as well as fraction part. The process remains same. The steps included to perform that subtraction remains same. Let us take an example and solve. In the first example, the above number is greater than the lower number. Of course, the subtraction will yield a positive number. Let us try to understand and perform the subtraction. Again, the rule says keep the first number as it is. So it will be 1101.101. So the first number remains the same. Second number, find 1s complement of the number to be subtracted. So 1s complement of this number will be 1010.000. All ones is converted into zeros and all zeros has been converted into 1. So for 0101 111, it will be 1010.000. So add the two numbers. So when you add the two numbers, what you get is 1 0 1 point. This is 1 0 plus 1 1 1 plus 0 1 1 plus 1 is 10. And so we have followed the three steps. After addition of the two number, now we have to check if the MSB produces a carry or not. So out of these two conditions, the fourth one will be satisfied. What is the condition? The MSB produces a carry. If MSB produces a carry, the answer is positive. Answer is positive. Bring down end around carry and add to the LSB of the result to get final answer. So this is your result now. This is not the final result. This is a intermediate result. What you have to do is you have to add the end around carry to this intermediate result to get final answer and to the LSB of the intermediate result. So in this number, which is the LSB, we have already understood or tried to understood that concept where I have explained you MSB and LSB. The number which is written on the leftmost corner will be always MSB because it has the greatest weight, and the number which is written on the rightmost corner will be always LSB because it will have the least weight. So this one, where it has to be added, the LSB of this number will be this one. So this one, that is end around carry, has to be brought down and added over here. So when you add these two numbers, what will be the number? 1 plus 1 10 0, 1 carry forward, 1 plus 0 1, 1.1110. So this is your final answer for this subtraction. So you get the positive number as your answer. So this is an example of 1s complement method where the number has both integer as well as fraction part, and the answer, the result will be positive. Let us take one more example to perform again subtraction, but the answer will be negative. Just reverse the number and we will perform so that we get the same answer. I'll just write it down, this answer somewhere here, so that you can see the result are same. 0111.110. This is your positive answer. Let us change the example and solve it again. Zero 101.111 minus 1101.101. Let us check. This is now the lower number minus the higher number, the lowest number minus the higher number. Of course, the answer will be in negative. Again, we have to follow the same rules to get the answer. So what is the rule? Keep the first number as it is. So 0101.111 remains as it is, and we have to find 1s complement of the number to be subtracted. So what is 1s complement of the number? It will be 1s complement will be all ones converted into zeros and all zeros will be converted into 1. So it will be 0010.011 0, and then you have to add the two numbers. Step 3. So when you add 1 plus 0, 1, 1 plus 1, 10, 0, 1 carry forward, 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 and this will be 1. Now, after the addition of two numbers, we will see, does the MSB or addition of MSB produces a carry? Do we get end around carry over here? No. So out of this 4 and 5th, which condition satisfies? The 5th one. If MSB does not produces a carry, what has to be done? The answer is negative. The answer is negative. We have to find 1s complement of the result. So you have to find 1s complement of the result. So what will be 1s complement? It will be 0, 1, 1, 1, 0.110. 011.110 and add negative sign to it. So negative sign has been added. So if the same example we reverse the number, of course we get the answer in negative, and compare this answer with the positive answer. Both are same, right? But here we have a negative sign. So this is how we have to use the rules for 1s complement method, apply for binary numbers, and in all these examples what we are doing is we are only performing addition, but the answer will be for subtraction. So this is the main advantage of using 1s or we can say complement method of subtraction. You perform only addition, but the answer is for subtraction. I hope you have understood.